Hi, Professor Wellman. This is Erin here to talk through questions 1 through 4 of quiz 8. So the first problem is to draw the FBD of the particles in the beam. At the ends of the beam enters a magnetic field. So we know that the beam has a vertical velocity the second it enters, and that the field is horizontal and perpendicular to the page in the above figure and out of the page. So at that point, all the force that is acting on the particle is the force of the magnetic field, which is, as this arrow is drawn, to the east direction. And find the speed of the particles. So I know that F of B equals Q times V times B sine theta. Sine theta is 90 degrees, so it's really just 1, so I just ignore it. And then rearranging that for velocity, since I know M times V squared over R equals FB, I can rearrange for velocity, plug in my numbers, and I get a velocity of 1.0510 e to the 7 meters per second. Excuse me. And then number 3, find the time of the particle beam to execute a semicircle. So I plug in another formula. Time is the distance traveled over velocity. And so I know the distance traveled by finding pi r. I have r, so just plug that in, and I just found the velocity, so I got 1.87 e to negative 7 seconds. That's super fast. And then, oops. Okay, find the sign of the charge of the particles. So the charge of the particles is negative, and I know this because of the right-hand rule, so I'm imagining grabbing hold of this velocity axis, if you will, and moving it to the direction that B is facing, which is 90 degrees this way. And so in doing so, my hand finishes with my thumb where it's in a negative pointing down position. So that implies it's a negative charge. Okay, that was a quick one relative to my past recordings. See ya in class.